Hello everyone. So in this video, we are going to see a question that is based on two-port network. So you have a given on kind of a ladder network, and in this network you have to find out the Z parameter. So one can either go with the star delta transformation, or there is some another approach to solve this. So if you just solve it by a star delta approach, you have to solve this particular circuit in multiple steps. Then you will be able to solve it, because here you have one delta. Okay, here you have one more delta. Like that, you have to convert the delta into star again, the star to delta. Like that, you can simplify, but it is too much time consuming also. Okay, so what can be the other ways to do that? So if I draw this particular circuit in another way, so I can find out some kind of symmetry here. So this is my 1 ohm, this is my 1 ohm, this 2 ohm I am breaking into 1 ohm and 1 ohm. Okay, so again this is my 1 ohm, so this is 1 ohm, 1 ohm, 1 ohm. Just I'm breaking down that 2 ohm into 1 ohm and 1 ohm. Okay, 1 ohm, 1 2 3 4 5, 1 2 3 4 5. Yeah, so here also 1 ohm I have. Okay, so you can basically split out this 2 ohm into you can say two 1 ohms. And if you see this particular network, you have you can deal this as a separate network. Okay, this as a separate network, kind of you can say you have T network that are connected in cascade. Okay, like that you can think of. So it has many T network, you can say, and all the T networks are connected in cascade. So T network 1, 2, 3, 4, 5. You have 5 T network that is connected in cascade. Now, uh, you have to find out the Z parameter, but if even if you know the Z parameter of this particular T network, you cannot multiply that Z parameter matrix to get the overall Z parameter matrix, because for cascade connection, your ABCD parameter gets multiplied. The ABCD parameter matrix gets multiplied, not the Z parameter gets multiplied. Maybe in another video I will demonstrate how things will happen for the Z parameter. But here, as of now, I am going to consider for ABCD parameter alone. So let's say you have one network, okay, that has a ABCD matrix A1, B1, C1, D1, ABCD parameter you can say here, and I have two network connected in cascade. Okay, this is my A2, B2, C2, and D2. Okay, so this two networks is connected in, you can say, in cascade. So if you find out the overall uh, ABCD parameter, let's say this is my V1, this is my I1, this is my uh, V2, this is my I2. Okay, and this is again, let's say this is my V3, and this is my I3, this is my V4, this is my I4. So if I write down the ABCD parameter relationship here in this case, V1 I1 is equals to A1 B1 C1 D1 ABCD parameter. It is simply V2 I2, V2 into I2. For this particular one, I can write the ABCD parameter as V3 I3 is equals to A2, V2, C2, D2, and V4, I4. Okay. And again, the V2 and V3 are same, and I2 and I3 are same. So I can just replace here V3 and I3 as a V2 and I2. And if you just put this V2, I2 value in this particular equation, so what you will get? You will get V1, I1 is equals to A1, B1, C1, D1, A2, B2, C2, D2 into V4, I4. So the overall ABCD parameter of this particular combination, you are getting multiplication of these two. So this is the matrix multiplication. Okay. So for cascade connection, if I know the ABCD parameter of this one particular T network, because all other T networks are same. So, okay, so I just need to find out the ABCD parameter for this network, and you have to multiply that matrix 5 times. And once you know the overall ABCD parameter of the entire network, then you can change that ABCD parameter into Z parameter. That we will see. Now, let me calculate the ABCD parameter of this T network first. This is my V1, this is my I1, this is my V2, this is my I2. Okay, so I have to formulate the equations in this form. V1 is equals to AV2 plus BI2, I1 is equals to CV2 plus DI2. I have to rearrange the equations like this in this way. Okay, so this in this part the current is I1 plus I2, right? So if you write KVL in this loop, what you will get? V1 is equals to 1 into I1 plus I2 plus I1 into 1. So V1 is equals to 2I1 plus I2. This is one equation. The same way you will get for this particular loop also. V2 is equals to I2 plus I1 plus I2. So V2 is equals to I1 plus 2I2. I1 plus 2I2. But I need V1 in terms of V2 and I2. I know I2. Now this I1 I have to get from here. So if we rearrange this equation, you will get V2 minus 2I2. You just need to shuffle, you can say, shuffling of the equations. You just put the I1 value in this equation, V2 minus 2I2 plus I2. So what you will get? V1 is equals to 2V2 minus 4I2 plus I2. V1 is equals to 2V2 minus 3I2. Okay, I know these things. Like V2 is equals to minus 3I2. Okay. Uh, and from here I know the V1 relationship. Let me find out the, okay, I know this from this equation also. I know like uh, V2, if you just look into these equations, I1 is equals to CV2 plus DI2. Okay, so this is my final equation. This is my equation 1, this is my equation 2. If I rearrange these equations in a matrix form, V1 I1 is equals to V2 minus I2. Okay. See, here I have considered this I2 is in the in the network, but actually for ABCD parameter, if you consider the I2 in this direction, that negative sign will not appear. So it is just your convention whether you took I2 in the inward direction or upward in the in the outward directions. Okay. So in since I have considered the I2 in the inward directions, so I have to take this minus sign. Okay, or else if you just consider I2 in this direction, then simply this minus sign will not come and you need not to worry about that. Okay, so you can also think from that point of view also. So if you just write down the equivalent parameter 2 3 1 1, 2. Okay. So this is the ABCD parameter. Okay. Like if I just consider, maybe I can give some clarity. If I just consider Ix in this direction, so here Ix is simply minus I2, right? So in place of minus I2, I can simply write Ix, then this minus sign it will not come. Okay. So just it is a notation, you can say. So for ABCD parameter, if a network is symmetric and reciprocal, in that case your A and D will be same. This is A and this is D. AD is same, that means it is a kind of a symmetric network, and for a reciprocal network AD minus BC must be 1. So you can calculate 4 minus 3 equal to 1. So it is like it is correct. So it is a symmetric and reciprocal network. So this ABCD parameter we must know, and once we know the ABCD parameter of this network, then we have to multiply this particular matrix 5 times to get the overall ABCD parameter. So if I calculate the overall ABCD matrix, 2 3 1 2, 2 3 1 2. So that will appear 5 times. Okay. So maybe I can do the multiplication from this side, or mm, is there any way to do that? Maybe we have to go with this general approach. So if you just multiply this particular matrix, you'll get 2 into 2 plus 3 into 1, 2 into 3 plus 3 into 2, 1 into 2 plus 2 into 1, 1 into 3 plus 2 into 2. So you will get 4 plus 3, 7, 6, 6, 12, 4, 7. Here also the A and D is same, and 12 into 4, that is 1. So this will be also be a symmetric and reciprocal network. So I know this thing, and I have to calculate, I have to do this matrix multiplication, this one and this one. So if I do the matrix multiplication of this and this one, so I can just remove this one. I can put here 7, 12, 4, 7. Okay. So do the multiplication again. So you will get, if you multiply this 2, 2 into 7 plus 3 into 4, 2 into 12 plus 3 into 7, 1 into 7 plus 2 into 4, 1 into 12 plus 2 into 7. Okay. So 2 into 7 plus 3 into 4, 2 into 12 plus 3 into 7, 1 to 7 plus 2 into 4, 1 into 12 plus 24. Okay, so you will get 2 into 7 plus 3 into 4, you will get 26. 2 into 12 plus 3 into 17, 26 into 7, 45. 1 into 7 plus 2 into 4, 15, 26. So 26 square minus 15 into 45. Yeah, again, so this is the thing that we are getting. So 2 into 7 plus, yeah. So you have to put this value here. So I'm just showing the result here. So here I have to represent here 26, 45. Whatever matrix you are getting, na, this is representing a symmetrical reciprocal network. So now you have to multiply these two matrix. So 2 into 26 plus 3 into 15, 2 into 45 plus 3 into 26, 1 into 26 plus 2 into 15, 1 into 45 plus 2 into 26. 2 into 26 plus 3 into 15 will get 97. 2 into 45 plus 3 into 26, 168. 1 into 26 plus 2 into 15, 56. 45 plus 2 into 26, 97. See, A and D is same, right? So 97 square minus 168 into 56. So you'll get 1. Yeah. So again, this is also a part of, you can say, symmetric and reciprocal network. So 97, 168, 56, 97. Okay. So if you, we have just started with uh, 1 ohm resistance of a T network, but that gave us this huge number because of 5 successive, you can say, networks. Plus 3 into 56, 2 into 168 plus 3 into 97, 1 into 97 plus 2 into 56, 1 into 168 plus 2 into 97, 2 into 97 plus 3 into 56. 2 into 168 plus 3 into 97, 197 plus 2 into 56, 2 into 97 plus 3 into 56. So what you will get? 362, 2 into 168 plus 2 into 168 plus 3 into 97, 627, 97 plus 2 into 56, 68 plus 2 into 97, 362, 7. Yeah. So A and D is same and AD minus BC is also 1. So this is the overall ABCD parameter of this particular network. But I need to find out the Z parameter of this network, not ABCD parameter. So how to proceed with that? See, for a ABCD parameter, the matrix is relation is something V1 is equals to AV2 plus B. If you consider like here, mm, here, if I consider I2 in the upward in the inward direction, then this negative sign will come, right? So for ABCD parameter. So minus I2, I1 is equals to CV2 plus D minus I2. Okay. So this is the ABCD parameter relationship. But I must get a relationship V1, V2 is equals to Z11, Z12, Z21, Z22 into I1, I2 format. This format I know. That means V1 should be Z11 I1 plus Z12 I2. V2 should be Z21 I1 plus Z22 I2. So that means I have to uh, write down the V2 relationship here because I don't want V2 here because from, let's say, this is my equation number 3, this is my equation number 4. From equation number 4, if I calculate V2 and if I put that V2 value into here, then this particular equation number 1 will become V1 will be function of I1 and I2. Okay, so let me calculate the V2 from here. So I1 plus di2 is equal to CV2. So V2 will simply 1 by CI1 plus d by CI2. So this is my equation number 5. Now put this equation 5 into equation number 1 from equation 1. Okay. So put this value V2 in this equation. V1 is equals to A 1 by CI1 plus D by CI2 minus BI2. So what you are getting here, A by CI1 plus AD by CI2 minus BI2, right? You are getting this. So A by CI1 plus you take the common C AD minus BC I2. Okay. So and AD minus BC is 1. So so V1 is equals to A by C I1 plus A by C I1 AD minus BC. So this particular term AD minus BC is actually 1. So 1 by C I2. 1 by C I2. So this is my another equations. So, and what can be done to get uh, huh, see this equation number 5, it is already function of ion and I2. So V2 is equals to 1 by C I1 plus D by C I2. Okay. So now I got the Z11 parameter. Z11 is simply A by C. Z12 is simply 1 by C. Z21 is equals to 1 by C. And Z22 is also D by C. Okay. So this is how the thing will happen. But is this calculation correct? Let me verify one more time. See, V2 is equals to 1 by C D by C I2. Hmm. So you know the A, and this is my A, this is B, this is C, and this is D. So you can write down the A and C values here and you will get the overall Z parameter. So I hope this process is clear. Although this network was like 5 cascade T network was connected. So, but in general, it will not be that complex, but I hope you understood like how to proceed with such problems, like when to convert into ABCD parameter and how to get the reverse like in the Z parameters and all. So I gave an idea like how to derive the things rather than memorizing the things. You can basically derive the process. You can and you will get the ABCD parameter because here you know the A, B, C, D and all. Okay, so you can basically calculate it. Yeah. But still, if you have any doubt regarding this discussion, you can ask me in the comment section. Okay. Thank you.